Whenever atoms decay, they give off radiation, particles or waves of invisible energy. There are three common kinds. Alpha rays can be stopped by very thin materials, such as a sheet of paper. Beta rays need more material, such as a thin piece of wood. Gamma rays can be stopped only by heavy shielding, such as lead or concrete. Why stop them at all? Because radiation can be harmful to the human body. Those people who use radioactive materials must control them. This is the story of how the United States Atomic Energy Commission licenses and regulates the use of nuclear materials so that the many benefits of atomic energy and man-made radiation can be achieved with safety. Atomic radiation is nothing new. It is indeed as old as the hills. Many elements which make up the Earth and the physical universe have atoms which give off radiation constantly and naturally. And so you and your ancestors, all the way back to primitive man, have been exposed to radiation as a natural phenomenon. This background radiation comes from outer space, from masonry and rocks, even from some of the materials in the human body. And to some degree, it touches us wherever we stand on Earth. Man survived in this environment of radiation long before he knew of its existence. But at the end of the 19th century, man-made radiation came into being. Wilhelm Röntgen discovered X-rays and built the tube from which they could be obtained artificially. Pierre and Marie Curie isolated tiny bits of the element radium, a naturally radioactive substance. The X-ray machine, with its ability to look into tissue, has revolutionized medicine. Radium, too, continues to have wide medical use. Rules for handling X-rays and radium have developed over a half-century. Our relationship to radiation was forever changed in the month of December 1942, when these scientists gathered under the stands of Stagg Field in Chicago as witnesses to the first chain reaction. Now man could control the breakup of the atom. Now he could produce radiation and radioactive products on a scale never before possible. The initial development of nuclear energy was military, but there is much more to the radioactive atom than a bomb. Scientists saw its peaceful possibilities from the beginning, and today the radioactive atom is hard at work in 5 broad areas of human endeavor. The first, power. The splitting of atoms in a power reactor provides both radiation and heat. The heat is used to make steam, and the steam roars through a conventional turbine whose generator makes electricity. The AEC is authorizing the construction of an increasing number of new nuclear power plants. They now have an installed capacity of more than 1 million kilowatts, a new pattern of power. Next, there is research. After 2 decades, the versatile research reactor is now an everyday part of our university and industrial life. It gives us more and more knowledge of the atom and its potentials. It is a training tool for men who are preparing for careers in the atomic energy field. Here, they learn to perform with precision and safety. Finally, the research reactor, making radioactive versions of ordinary substances like carbon and iodine, has put radioactive atoms directly into industry, medicine, and agriculture. In industry, radiation provides new precision and quality control. Radioisotope gauges set the rollers to roll this steel to precisely the right thickness. Radiation improves safety. Radiography of a pipe weld shows up any faults and prevents possible pipe bursts and leakage in natural gas transmission. radiation helps make better products. Particles that wear from this special piston ring contain radioactive iron. Measurement of this radiation in a test engine enables the engineer to determine engine wear and design a better engine. The fourth area is agriculture. Radiation makes for a new productivity. Scientists can now find how a cow's food relates to her milk production. And by changing the structure of seeds, radiation is creating improved products, such as a blight-resistant peanut with a tough hull which resists cracking during harvesting. And finally, medicine. Radiation helps to diagnose and it helps to cure. The heavy marks show where concentrations of the administered radioiodine have gathered in an abnormal thyroid gland. A teletherapy unit using radioactive cobalt bombards a deep cancer with minimum damage to surrounding tissues. 20 years of experience have taught us that man-made radiation can make our life richer and safer. Whenever men work with atomic radiation under AEC license, this symbol is present by law. It warns of a hazard. Radiation can be dangerous. Because the hazard depends on the amount of exposure, even low levels should be approached with a sense of awareness. Some of the hazards are potentially great. Irradiated nuclear fuel must be shipped in a massive specially designed cask. On the other hand, a wristwatch with radioactive tritium to make the dial glow in the dark needs no shielding and is not hazardous. So radiation takes its place with the other hazards in our complex civilization. Man-made hazards have always gone hand in hand with man-made progress. The curve is not dangerous if you round it at the right speed. Nor is radiation dangerous if you handle it in the right way. It is the responsibility of the Commission to see that the right way is followed. Many safety precautions are built into equipment like this, which senses the density of soil. But the prime safety ingredient is the user's knowledge of the system. The insignia reminds the atomic worker to treat radiation with respect, and he does. There are about 9,000 organizations and individuals licensed to handle radioactive material. For 20 years, thousands of people have worked safely with man-made radioactivity in and out of AEC plants. During the past 3 years, AEC-owned plants have achieved a safety record which puts them among the 5 safest industries in the nation. How then will the excellent record of the industry be maintained as more and more nuclear work is undertaken by private industry? Through a control program administered from the AEC headquarters or from a state headquarters where some of the control has been transferred from the AEC to the state. The AEC regulatory program is headed by the Director of Regulation, who reports to the Commission on the work of his 3 divisions. The Division of Licensing and Regulation prepares regulations for the use of radioactive materials and licenses their use by commercial firms, educational institutions, and others. This division assures through inspection and examination that the material is properly handled. The Division of Radiation Protection Standards participates in developing standards and in ensuring their uniform application in both AEC and state regulations. The 3 divisions are closely linked. They work together on the single big job, safety of the public and the atomic worker. At atomic energy sites, as a matter of general safety, the public is kept at a distance. The atomic worker expects a certain controlled amount of radiation, but he keeps his distance too. He also wears equipment such as a film badge which measures the amount of radiation accumulated over a given time. This amount is strictly limited, and as necessary, he is shielded. The shielding depends on the type and amount of radiation. It may be a pair of rubber gloves, it may be 20 feet of water, it may be tons of concrete. Uranium is a basic material in the atomic energy program. In the United States, most uranium lies in the ancient riverbeds of the high Colorado Plateau. Each state is responsible for safety in its mines. When the ore goes to the mill, AEC regulations are in effect to protect workers and the public. The mill operators must hold wastewater in a settling pond to control any release of radioactivity to the environment. Stack gases and other effluents are also filtered and checked to see that the mill does not release excessive amounts of radioactive materials. Care is also taken inside the mill to protect employees. Uranium oxide, or yellow cake, leaves the mill in 55-gallon drums. It has a very low level of radiation. Nevertheless, the shipment rides under safety rules with appropriate markings. Thousands of individual shipments of radioactive material take place each month, from tons of yellow cake to tiny fractions of an ounce of radioiodide. Safe and speedy transportation is essential to the development of atomic activity, and the transportation industry has responded effectively to the new needs. Each shipment presents its own problems. Purified and enriched uranium has been loaded into bird cages for shipment. It is on its way to a plant where it will be made into reactor fuel. Why the bird cages? Because if a sufficient amount of this enriched uranium is brought together, a chain reaction could result, releasing large amounts of heat and radiation. By their construction, the bird cages lock the material in a harmless pattern. Most non-military uranium is put to work in nuclear reactors. But before any AEC licensed reactor, large or small, power or research, can receive a load of fuel, a long and careful preparation takes place. Similar procedures are followed for reactors owned by the Commission itself. In this AEC reactor at Oak Ridge, uranium arrives to serve a different purpose, to produce radioactive materials called radioisotopes. Here, phosphorus, sulfur, calcium, iron, cobalt, copper, zinc, and other elements are made radioactive by nuclear bombardment. These useful radioisotopes fan out all across the nation, but the system for protecting the public and employees follows them everywhere. Here is the careful way in which a shipment of radioiodine is prepared at an atomic pharmacy. The worker is shielded by a thick, heavy wall and does his work by remote control. Behind the shielding wall, the storage bottle and the smaller shipping bottle meet at the transfer table. The shipping bottle is transferred to a container and the container to a shipping box. Only when the top has subsequently been placed on the protective shipping box is the radiation level low enough to bring the radioisotope from behind the wall. A smear test shows that no radioactive material has stuck to the surface. A radiation meter shows that surface radiation is within safe limits. After weighing and labeling, the shipment is on its way carrying its own warning sign, as does the truck, which takes it to the airport. Next morning, the radioisotope will be at a hospital 2,000 miles away. More than 100,000 radioisotope shipments are made safely each year. But not all are this small, of course. Larger, potentially more dangerous shipments require more shielding. The top of this cask of radioactive material is bolted into position. What about the men and women who receive these shipments? Lab workers, botanists, technicians, soil scientists, doctors, the host of people who must each day handle radioactive byproducts in order to do their work. The AEC requires that these people be instructed in the safety problems associated with exposure to radiation from radioactive materials and in precautions and procedures to minimize exposure. They have either taken a formal course or have worked closely with a senior individual whose qualifications have already been established. These people know the rules and they follow them. In some states, certain licensing functions have been turned over by the AEC to the state government under congressional authorization.
Gentlemen, I'd like to begin by introducing my fellow commissioners. On my right is Commissioner Mary Bunting, who is on leave to the Atomic Energy Commission as president of Radcliffe College. And on my left is Commissioner Gerald Tate, who is a former head of the Brookhaven National Laboratory. It's a pleasure for us to welcome you here this morning as representatives of the first states, 9 states, I believe, that have assumed a part of the Atomic Energy Commission's licensing and regulatory authority. You are truly trailblazers in the field of nuclear energy and federal-state relations. As you know, nuclear energy was born in a wartime setting, and for a number of years it was carried on entirely under federal control. But we've always looked forward to the time when this new source of energy could take its place more in the mainstreams of our society. The scientific and industrial communities quickly recognized the tremendous potential of nuclear energy, this potential in education and in research, research in agriculture and in industry and in medicine, and of course its potential in generating electricity. And as these peacetime uses grew, it became logical to look to the states because of their traditional role in the regulation of public health to play an increasing role in this new force. As you know, historically, the control over X-ray equipment and radium has always been a state responsibility, and thus it was only a matter of time when the states would take over some more responsibility in the regulation of parts of the nuclear energy field. So that in 1959, Congress approved legislation under which the states could assume part of the regulatory authority over radioactive isotopes and the source materials, uranium and thorium, and small amounts of fissionable material. And I should like to point out that this is a concrete example of where the federal government is relinquishing part of its authority to the states, which perhaps runs counter to the popular view of this relationship. Assumption by a state of part of this regulatory authority, of course, carries with it both opportunity and responsibility. Opportunity in that it increases the possibilities of nuclear energy activities locating in your states because of the existence in your states of this state regulatory function, and of course responsibility to assure that the regulatory program is carried on in such a way as to assure the public health and safety. Now, meetings such as this one between the Commission and the states are an important part of this federal-state relationship. It's through such discussions that we are able to achieve a better understanding of our problems and our respective points of view, as well as assure the maximum degree of uniformity and compatibility of our programs. So my fellow commissioners and I look forward not only to the meeting with you 9 representatives today, but we look forward to the day when there will be representatives from 50 states sitting around, well, not around this table, but a larger table to carry on these important discussions. Now I'd like to begin the discussion by asking if there are any of you who would like.
and whether the regulatory control comes from the AEC or an individual state, it is a continuing matter. Any licensed radiographer, a man who moves from job to job about the country with his radiographic camera, can expect to see this man at any time. He is an inspector from the AEC Compliance Division or from the state. He will ask to see the exposure records of any person working for the company or to look at records dealing with the receipt and transfer of radioactive material, probably cobalt or iridium. He will be interested to see whether the work area is roped off and properly guarded by the right signs. He will check the radiographer's camera to see that it is the same type of camera and radiation source indicated in the license, that it has no excessive external radiation with the shield closed, that it is stored properly, and that it works safely. He also will observe an actual radiographic procedure to see that the work is carried on in an established, safe pattern. As with the reactor inspector, the control continues. And of course, there is a procedure for revoking a license as well as granting one. But in spite of all precautions, there are sometimes accidents involving radioactive materials. AEC radiological assistance teams are available from a number of AEC sites across the country. Members of the teams are trained and equipped to deal with radiation hazards. Though normally occupied with other work, these team members are on 24-hour call in case of serious trouble. A truck carrying radioactive material has been in an accident. Some material was released. The assistance team determines how much has been released, the area that has been contaminated, and the radiation hazard that may have resulted. After the major portion of the spilled material has been removed, the area is given a final washdown. The team supervises this decontamination of the area and also determines if anyone at the scene could have been exposed significantly to radiation. And the team remains until all steps have been taken to control the radiation hazards. In addition to the AEC, there are other federal and several state agencies that respond to protect public health in case of radiological accidents. There comes a time when radioactive material must be reprocessed or disposed of. Uranium fuel is sent to reprocessing plants. Here, at the end of the trail, all safeguards are still in effect. At present, all highly radioactive wastes from reprocessing are stored underground. But low-level wastes may be disposed of safely, and several firms are licensed to collect and dispose of this material. Regular collections are made, and the rules for transporting waste are set forth in safety regulations. Even though no longer useful, this is still radioactive material, giving off a small amount of radiation. And each container is marked to show both contents and radioactivity. A small percent of low-level radioactive waste is prepared for burial deep in the sea at approved locations. The radioactive material has been surrounded by concrete in a steel drum before the drums are taken out to sea. The drums meet specifications which assure that they will remain intact to a depth of 6,000 feet. But most low-level waste is buried on land at burial grounds owned and controlled either by the AEC or a state. The wastes are buried deep enough to shield the radiation coming from them. Sometimes an additional cover of concrete is added over the dirt. But even then, the job is not over. Groundwater in the area is constantly monitored to see that it does not ever contain more than permissible amounts of radioactivity. This is the last act in the long chain of surveillance for protection of the public. What is the primary aim? To see that there will always be intelligent control of radioactive materials. from the time uranium leaves the ground until it and its byproducts return again to the ground or the sea, men and women of the AEC and the state control groups labor to see that radioactive materials are used fruitfully and safely for the benefit of all of us.